Okay, have a nice day, everybody. This will be the video for the simple exponential smoothing that we'll be going to deal with. Since we're able to discuss already how we could be able to work on with the with the weighted moving average or the moving average model. So in this video, I'll be going to illustrate to you how we could be able to work on with the simple exponential smoothing. So in this case, we do have a data set right now, which hey per year then 2000 and 5000 and I mean 5000, 6000 up until 10,000 data set, and we are having there the um we will be going to use that one. And by the way, just to let you know that for the alpha of this one, for example, the alpha is being set into the alpha parameter, we could somewhat say that that is already given since okay, so I'll begin to give you a specific parameter of alpha. For example, our alpha right now is 0.7. So that will be our smoothing parameter that we'll be going to take note in every case right now. So this is somewhat really serious in how to calculate that one, because you will need to work on that in a step-by-step manner, and you really have to deal with this carefully. Now then, the formula that we'll begin to use is this one, the smoothing, the alpha times yt plus 1 minus a, then st minus and minus 1. Now, for this one right now, you have to definitely, for S2000, you have to initialize first. Your S1 or S2000 is definitely equals to the Y1. So your S1 right now is 2000, so that is 5000, because that is actually given that your S1 must equate to your Y1. So your Y1 right now, when we say YT, that is your data set. So the 2000, year 2000 is having 5000. So that means to say the score of your S2000 is equals to 5000 already. That's how you will deal with the simple exponential smoothing, that your S1 must equate to the Y1 already. Now, after that one, you have to apply the formula as being mentioned. As we have stated already, because of course here then we're not getting the level, we're not getting the trend already, but as being mentioned in our data, that instead of we'll begin to get the average um for the initialization, we'll just use this one as S1 is equals to Y1. Now for the S2 1001, our formula, we can definitely use the formula already, which is your alpha, distribute that one 0.7, multiply that into what is the data for 2001, that is 6000. Okay, that's how you will deal with that. Plus 1 minus 0.7, and then times to the ST minus 1. When we say ST minus 1, you're actually right now in S2001. When you will begin to deduct that into 1, S2001 minus 1, that will equate to S2000. That is the previous um forecast or smooth out data, because we're just smoothing out the data right now. The smooth data for 2000, that is 5000. So we can definitely put that right here as 5000. So we'll just calculate that one 0.7 times 6000. You need to do it step by step, because of course it must be step by step. 4200 plus 0.3 times 5000. And for here then, 4,200 plus 0.3 times 5,000, that is 1,500 here. And for that one, you have to add that into the, and that will equate to 5,700. So the smooth data for S2001 is 5,700. So just to take note that our goal for this one is we'll begin to forecast um since in order for us to forecast, we need to smooth out the data first. So this is our smooth data for the 2000 and 2001. So by the way, our goal is to forecast from 2006 to 2010. So we'll forecast that one in later on. So we'll begin to deal with that one by one. And right now we'll begin to proceed with the 2002. How to deal with the 2002? So you really need to definitely calculate the same thing as what we have did earlier. So you were able to distribute only 0.7, then times into the 7,000 already, because that is the data set of 2002, and then plus the same thing, 1 minus 0.7. Then the previous data or the smooth data as ST minus 1, that is 2001, and that is 5,700. So that's how you will deal with that. And 0.7 times 7,000, that will become 4,900. And then plus 0.3 and 5,700. And then 4,900 plus 0.3 times 5,700, that equates to 1,710, plus 4,900, that will equates to 6,610. So therefore, this is the smooth out data for 2002. Now let's proceed to the 2003. For S2003, that is still then 0.7 times, you're having the data set as 8,000 for 2003. So distribute that, and plus 1 minus 0.7 still. Then your previous ST minus 1 is 6,000, 6,610. So it will become 0.7 times 8,000. Make sure to do it step by step. 5,600 plus 0.3 of 6,610. So right now, 0.3 times 6,610, that will become 1,983. You will begin to add that into the 5,600. That will become 7,583. So this is the smooth data for this for the year 2003. And we'll proceed with the 2004. For the 2004, that will become 0.7 times, you have the data set as 9,000. So you'll just going to distribute everything, plus 1 minus 0.7, and then your previous forecast or smooth data is 7,583, and then your 0.7 times into 9,000, that will become 6,300, plus 0.3 then 7,583, and then afterwards 0.3 times 7,583, that will become plus 2,274.9. Okay, plus 6,300, that will become 8,574.9. So this is the smooth data for the 2004. We'll proceed to the 2005. So for 2005, you will begin to, you have the data right there as 0.7 times 10,000. Let me check. That's 10,000, right? Yeah, that's correct. So afterwards, here's 1 minus 0.7. Then your previous smooth data, it's 8,574.9. And then you're having here as 0.7 times 10,000. That equates to 7,000. plus 0.3 times 8,574.9 times 0.3 times 8,574.9. That equates to 2,572.47. You will begin to add that into the 7,000, and that will equate to 9,572.47. And this will be the smooth data for your 2005. Then afterwards, you will be going to forecast already. For getting the forecast for the simple exponential smoothing, you just have to actually use the current data set, which is you're having the update already as 9,572.47, and that will be your basis as well for the previous, and your data that you'll begin to use for the data set is always the current data or the recent data, which will be the 10,000. So you will always use the 10,000, since that is the recent data. You will begin to use that as well right now here in this category. So that will become 0.7 times 10,000, then plus 0.3. No, no, no. I just go directly. No, you have to do it step by step. Then 9,572.47, and then 0.7. No, no, no. It will become 7,000 plus 0.3 times 9,572.47. So you just calculate that one times 0.3. It will become 2,871. So that is 7.74. And then plus 7,000. Okay, that will become 9,871.74. So this will be the forecasted data for 2006. What about for 2007? So that will become 0.7 times 10,000 plus 1 minus 0.7, then 9,871.74, and then the same thing, 7,000 plus 0.3 times 9,871.74, and then you will be going to times that into 0.3, and that will become 2,961.52. And then you will be going to add that into the 7,000, and that will become 9,961.52. So this will be the forecasted data for 2007. And for 2008, you have to continue still then the same process, since you don't have a current data. So you will just use the data for 2005. That's how we actually organize in this one. Then 1 minus 0.7. This is the same thing. You have to implement the same and then it will be connected, because of course, class, if you were not able to calculate that carefully, once you are actually having is wrong in the first part, then in latter hand, it will be wrong automatically. So that's why you have to be very careful in terms of your calculations about this, because I will not be going to um, check that in the latter part if you are already mistaken in the on the first hand. So it is 2,988.46. You just have to round it off once if it is greater if the next You just only have to observe two decimal points and then just round off everything. So, no. You just have to add 7,000. So it will become 9,988.46. Okay, for the year 2009, so this is the forecasted data. Okay, for the year 2009, and that is 0.7 times 10,000 plus 9,988.46. It will become 7,000 plus 0.3 of 9,988.46. So that will become 0.3 times 9,988.40. Sorry, let me just calculate that on 0.3 times 9,988.46, and that will equate to 2,996.54, and that will become 9,996.54. And that will be the forecasted data for the 2009. So for the forecasted data for 2010, it will become 0.7 times 1,000. I don't know, 10,000. This is not 1,000, okay. That is 10,000. Remember that we're having 10,000. So 1 minus 0.7 and then 9,996.54 and then 7,000 plus 0.3 times 996.54. Okay, 99. That is 996.54 times 0.3. That is 2,998.97. So plus 7,000, that is 9,998.97. So this is the data for up until the year of 2010. So make sure if you will be going to draw that in a graph, so that you could definitely observe the fluctuation as well. For example, I'm actually wanted to put that here, for example, in 2000, 2000, 2001, 2002, 2003, 2004, 2005, 2006, 2007, and then 2008, 2009, and 2010. Okay, say for example, we'll begin to just, this is just a approximation that will be just draw it accordance with that. So for example, this is the place of 5,000. This is the place of 5,700. This is the place of 6,6,100 and 7,583. This is the place of 8,574.9. Then 9,572.47. So we'll be going to draw first the for the smooth data. Okay, this is the smooth data. And okay, that is the smooth data, for example. And for this one, since you were able to get for the 2006, which is 9871. So it is just a small fluctuation that it is somewhat increasing 9899, 998, so 996, 99. It actually down there is a downtrend in 2009. So you can somewhat imagine that it's somewhat like that, for example. So there is a fluctuation something, then you will have to explain what is going on with the simple exponential smoothing. So of course, class, this is really simple for the simple exponential smoothing, and I know that you can do it. So thank you so much and goodbye, and see you in the next video for the double holds, um double smoothing already.